Today we will download and install one of the freely available electronic simulation software called Saml IDE. I will show you how to download and install this software on your computer, and then I will do a little demonstration by building a simple circuit how to operate this simulation software to analyze your circuits. So my name is Shazad, and in this channel I make videos on electronics, computers, technology, blockchain, and some other topics. Electronics is one of my hobbies, and I'm planning to make some videos on electronics with some basic concepts, and for that purpose I will be using the Saml IDE for the demonstration purposes. Using the simulated environment for testing your electronic circuits is a very preferred way to learn the electronics. The other way is that you bring the physical components and get it connected on the breadboard and test your circuits. The problem is that you must have the correct components and with the correct values, and you must connect those circuits correctly on the breadboard. And if you want to make some changes into the circuits, you must have the correct values of the components. So using the simulated environment, the good thing is that all the components that you need to build your circuits are always available, are readily available into the simulated software. And all you have to do is to build your circuits using the simulated you can say a breadboard. So and even you can change the values of different components, like for example, if you need a different value of resistor to change the behavior of your circuit, you can simply change the value of the resistor. Alright, so to download the software you have to go on the SimulIDE.com, and you can see that the opening statement says that Saml IDE is a simple real-time electronic circuit simulator intended for the hobbyist or students to learn and experiment with simple electronic circuits and microcontrollers using PIC, AVR, and Arduino. So that is one of the main reasons that I use this simulated software for testing my electronic circuit, because not only I can build my simple circuit, but I can also test and build circuits using some microcontrollers like Arduino. And in future I will make some videos how to use make some sample circuits using the Arduino microcontroller. Alright, so to download the software you click on the downloads link, and there you have the download for different operating systems. I'm using the Linux, so I will be downloading using this link. So if you click on this link, this will start downloading the software. It's depending on your internet speed, it may take, but it's a small download, only 35.8 MB of download. Okay, I have already downloaded the software, and this is the app image. So app image, you can say, is a single executable file that you can download on the Linux operating system. It's a single executable file that contains all the software. All you have to do is that you simply download this app image on your computer and start using it. It's a very convenient way to use a specific software. You can see that I have some other app images of different softwares. It's my favorite way. Whenever I need the software, I first look for the app image. So anyway, if you want to execute this app image, just make sure that it has the right rights or the permission to execute. Right click on the file and go in the permissions, and there you have a checkbox, allow executing file as program. Make sure that this checkbox is checked. So once that is done, you are all ready to start this program. Simply double click on the program, and there we have this simulated environment. And so you can download this software for other operating systems like Windows. Simply download the installer and then install it on your computer. And once installed, if you start the program. This is what you will see when the program is started. Your simulated environment is now ready and you can start making your circuits right away. But before I make a simple circuit and analyze it, let's review the components that are available on the left side, and you can see that there are a large number of components that are available in this simulated environment. And that is the main reason that I will recommend that you should be using a simulated environment to test and learn the electronics, because having all these components physically is going to be a large investment. Like for example, the voltmeter, the frequency meter, the oscilloscopes, these are a bit expensive equipments to have. So let's quickly review some of the components we have. The first grouping of the components is the meters. You can see that there is a probe, then there are voltmeters, amp meter, frequency meter, oscilloscopes, and the logic analyzer. And the beauty of this simulated environment is that you can have multiple the components on your breadboard, and you can start analyzing your circuit. So that is one big advantage you have in this simulated environment. The second group is the sources of different voltages. There is a fixed voltage. One thing that you can notice is that if I right click on a component and go into the properties, I can change different properties. Like for example, if I change the voltage to 10 volt or maybe 10.5 volt, and you can even change it to milliwatt. And so what happens is that now this component will provide a constant 10.5 milliwatt. So the thing that I want to show is that most of the components, if you right click on that and go into the properties, you can change different properties of this component. Alright, so you have the fixed voltage that will provide fixed voltage whatever you configure it. Then you have the clock, and again if I go into the properties, you can see that there's not only the voltage but also there's a frequency parameter, the 1000 millisecond. That means that in 1 second it will produce 1000 cycles, and that is basically a clock. That means that this is a digital frequency, which means that either the output is 0 or 1 based on the frequency that you will set. Alright, so then you have the wave generator as well. So again, it will generate the sine wave. If I go into the properties, again you can set different properties including the voltage and the frequency that this component will produce or provide to your component or your circuit. And then you have different voltage sources as well. You can see that it's basically the variable voltage. So during while you are analyzing the circuit and simulating the circuit, you can change its voltage. Alright, because it's not running, so let's try to run it and see that is there any voltage. Yeah, there's it. So you can see that the maximum voltage is 5, and you can change it from 0 to 5. And I think let's stop the simulation and let's go into the properties. And again, you can set the maximum voltage starting from 0 to the maximum voltage. So if I set it 10, then the maximum voltage this source can provide is 10. Alright, so that's the variable volt source. Then there is a current source as well. So this will provide a whatever current that you will configure, and as it is a variable current source, so you can change the amount of current that this component is producing or providing to your component. You can change this through this component. If I click on the if I right click on the component, again you can change the amount of current, the maximum amount of current that this component will provide. The maximum is right now 1 ampere, but you can change it 2, 3, 4, 5, whatever ampere you want to produce. Then you have the constant, you have the battery source, and there's a positive negative terminals, and again go into properties and you can change the maximum voltage this battery will provide. And of course, I mean, this is a fixed voltage, so whatever you set, I mean, that voltage will be provided to your circuit. And of course there's a ground. I'm not sure what is this component, but I will find out where. Anyway, then you have different switches. There's a push switch, and then there is a simple switch. The difference is that if you on this component, if you press it, then it will close the circuit. Otherwise, in the normally it will be open. And the switch, basically, if you click on it, it will be closed unless the next time you click it and it will be open. So that is how you can change during the simulation of your circuit. You can change the flow of the current using these components. And there are other switches as well. There is also keyboard. If I drag it over here, and you can see that if using the mouse wheel, I can zoom in and then zoom out. One thing that I found is that the zooming will happen where the mouse cursor is pointing. So for example, if I want to zoom over here, so I can do that. If I have to zoom over here on this component, so on this part of the circuit, so I have to put, so the thing is that, I mean, I don't see any scrolls over here. So what if I so I cannot move the breadboard while I am on a specific zoom level. So if I want to zoom on a specific circuit area which is outside this view, so I have to zoom out and then put my mouse on that specific area, and then it will zoom on that area. So anyway, maybe, I mean, in future we will have some controls over here that I can, without zooming out and zooming in, I have some the scrolls on the left and the bottom, so that I can change it. In fact, yeah, I mean, that's the scroll for the components. All right, so these are different switches. Then you have different passive circuits, components like resistors. If I put the resistor over here, it's by default the 100 ohm resistor. On right clicking and go into the properties, and you can change the amount. For example, I can also change it to mega ohm as well. So now this will be 100 mega ohm resistor, or maybe I can change it to milli ohm, and then this is a 100 milli ohm resistor. So this is how you can change the values of the component of your resistor. And that is what I was telling you, that, I mean, the beauty of the simulated environment is that you can change the values of your components, and you can again start your simulation and see the behavior after you make changes into the values of the components. So anyway, quickly going other components, you have potentiometer, variable resistors, then you have the capacitors, electrolytic capacitors, and the inductors. Again, if you place it over here, and by default it's a 1 Henry inductor, right clicking it and you can change the values as well. And then you have the active components, the diodes, the volt regulators, op amps, and some of the transistors. For example, if I place the BJT transistor, if I click on go into the properties and see that, so you can change the gain and PNP of this transistor using these properties. Similarly, if I go MOSFET, place a MOSFET over here and go into the properties, and you can see that I can change different values of this MOSFET based on what I need for a specific circuit. So that's how you have it. And then you have the different leads, LEDs, like this is a simple LED. It will turn on or off based on the voltage that you will provide. If I right click it on over here, and you can see that the threshold and the maximum current, you can set these different values. The resistance that this LED will provide will be 0.6. So you can change these values as well for this LED. And you have different other LEDs. Then you even have the matrix of LEDs, so you can change, you can control different you can control this matrix using these inputs. So in future we will be using these components in our circuit when I will be developing some sample circuits. Alright, then one of the important things is that you will be using while you are using different microcontrollers, you have different displays. Like this is one of the displays, I mean in a hard form, that is the 44780, and all the inputs that you have, you connect it with your circuit, most probably with your microcontroller, start feeding the signals to this component, and then it will start displaying different according to whatever you are feeding to this component. Alright, so and then you even have these LEDs as well into the system. Alright, so and moving on, you can see that you have, I mean, this is something I want to show you, that there are different PIC microcontrollers. Then there's Arduino microcontrollers. If I drop down, you can see that different variants of the Arduino, the Uno, Mega, Nano. If I place this microcontroller over here, you can see that, I mean, this microcontroller is over here. So I mean, using this microcontroller in this circuit, you have to feed your program into it, and then it will start running this program. This microcontroller will start running this program when you start the simulation. So in future I will show you that how to use these the Nano and the Mega microcontroller, Arduino microcontrollers, and how to program them. And then you have different logic gates. These are just simple logic gates that you can place on your breadboard. The buffer, the AND gate, OR gates, XOR gates. Simply drag it, and that the component is on the breadboard, and you can start. So these are the you can say the generic, but if you want a specific ICs, then ICs are also there. You can see that, I mean, different ICs. In fact, there are different ranges of the ICs. So if I drop down, you can see that there is a large number of ICs that are also available into this simulated environment. Just drag it on the component, and you have the IC, and you connect the inputs and the outputs with your circuits, and then you can analyze the behavior of your circuits. So the thing is that, I mean, you can have any number of ICs on your component. So different ranges of the ICs are available. This is IC74 and its ranges, and then the ICCTs. So I mean, I can see that there are JF flip-flops, ICs, and other ICs into the component. Anyway, I'm not very much familiar with all of these ICs. Some of them, all you have to do is that you can have the inputs and the outputs and the details and the documentation from the internet, and then you can start using these ICs in your circuits. Then you have the keys. I have not used these keys before. Maybe in future, when I will be learning about these things, I will make videos. So anyway, so these are your logic components, and then you can have some graphics as well on your component, on your circuit. So you can place an image over here. It's just a static information when you are making some screenshots of your if you want to have some text, your lines or eclipse, or some images, so to explain your circuit, so you can have it, and then it will produce, and then you can produce some screenshots and other things, and then you have some other components. So this is, you can see that, I mean, there is a large number of components that you have into this simulated environments, and so we will be using most of these components in the future videos when I will be making simple circuits to advanced circuits, and using the microcontrollers and explaining those circuits in details. And so we will be using those components. Okay, in the last, let's build a simple circuit and do some analysis using different meters. Analysis of your circuit. Let's place a diode over here, then a push button over here, and then a resistor in between, then a fixed voltage 5 volt, and then the ground over here. And let's replace it with, you can remove this component by right clicking and remove, and let's place the switch over here. All right, so, and let's connect the components together. To make the connection between the components, place your mouse cursor on one of the components input or outputs and click it and drag it to the other component, and then again click it, and there's a hard connection between the two components. And if I rearranging my components, the hard connections will not break. In fact, it will rearrange the connections as well. Let's connect with other components as well. Sorry, it's not that. No, I don't need that diode over here. I need the LED over here. And let's place it, connect the LED with the resistor, and that's it. Your circuit is complete, and now you are ready to analyze the circuit. And for the analysis purpose, you simply to start a simulation, you simply have to click this red button, and your circuit is now in the simulation mode. And you can see that your LED is not turned on. The circuit is right now in the simulation mode. To turn on the LED, the first thing is that you have to turn on the 5 volt source, because it is in the off state. To turn on the 5 volt source, you can see that there's a box over here. Just click it, and the 5 volt source is turned on, and then you close the switch, and you can see that your LED is turned on. All right, so let's start by changing some values of this resistor. And the thing I want to show is that while the circuit is in the simulation mode, you can change the values of different components. So go into the properties, change the value of this resistor to 10 ohm, and now you can see that there is an indication that there's too much current that is flowing through this LED. It's because this resistor is allowing too much current through the LED. To limit the current, of course, you have to increase the resistor value. Let's change it back to 100, and now you can see that the LED stop blinking. The point I want to make is that while the circuit is in the simulation mode, you can change the values of your components, and the circuit will start behaving according to those values. So okay, let's analyze the circuit with different props that we have. Let's start with the logic prop. Just drag it on the breadboard and place it at some point, and you can see that the prop will show you what is the voltage at that point. You can move it to other point, and you can start analyzing your circuit with this prop. What is the voltage at that point? You can also place it, and you can place multiple props on your breadboard, and it will all show you the voltage at that specific point. So you can see that there's a voltage drop across this resistor. Alright, so let's place a voltmeter over here and place it across the resistor, and it will show me the voltage across this particular resistor. So you can see that what is the voltmeter is showing me that is the voltage across this resistor. Similarly, I can place multiple components on the on the board, and let's place this voltmeter across the LED, and you can see that this is what it is showing me. Sorry, I think I placed the amp meter. Let's place the voltmeter. Alright, so that is the voltage across this LED, and then I can also place the amp meters, which measures the current through the circuit, but for that purpose I have to remove this connection, and then I place it and connect the circuit, place the amp meter across the circuit, and you can see that that much current is flowing through this circuit. You can have multiple amp meters, and you have to use the amp meter, you have to connect it across the wires, and of course it's going to show me the same amount of current going into the ground. And so that is how you can place different components, use different voltmeter, different meters, and measure what is happening at specific point of the circuit. So let's change the value of this resistor. Let's make it go into the properties and make it 10 ohm resistor. And immediately you can see that there are some changes into the circuit, and you can see that I can change the values of different components while the simulation is running, and the circuit will start behaving accordingly. And you can see that there's an increase in the amount of current that is flowing through the circuit, and that is why this LED is blinking, which indicates that too much current is flowing, and this may on a physical component it will definitely burn the LED. So let's change the value of this resistor again to 100, and that will stabilize the LED display as well as the current that is flowing through the circuit. And you can change it, let's see, to 80, and then you can see that the amount of current that is flowing through the circuit has changed. So that is how you can use different components and different meters to analyze your circuit. You even can have the oscilloscopes, the logic probes, and of course you can have any number of components on your circuit and do your analysis of your circuit. So this particular software, Saml IDE, you can use this simulated environment for the learning purpose. You can build your simple circuits, you can even build your moderate to complex circuits, but to build a final to the professional level circuit analysis, you need some other softwares available on the market which are obviously paid, and they give you more accurate results. It's recommended that if you are doing some professional works, you use those professional simulated environments, but this simulated environment is more than enough for the hobbyist, of course. And if you are making some simple circuits, this circuit will make the accurate analysis of your circuit. And let's close this video. But now in future I will be making some more. I will start making some more videos, starting with some simple circuits and simple concepts of the electronics, and then we will start making some complex circuits. Like I will be doing a demo of the 555 timer. I will be making the 555 timer using the basic components, and I will show you exactly how the 555 components works. But before that, I will be making some videos with some simple circuits and the simple concepts about the electronics. If you like this video, click the like button, and you can also subscribe to my channel. I make videos on science, technology, computer, electronics, and different other topics. So when I upload those videos, you will get the notifications.